Hello there reason people, PoohBear here and welcome to my channel. Today we're going to be diving down the rabbit hole to do with the remote codec. It's quite a deep hole as well. Now going forward, whenever you hear me reference the word codec, I am referring to as LuaCodec because there's also a Midi codec and we will actually touch on that. Now on my channel I do happen to have quite a few videos to do with the actual Midi codec side of things. So it's probably, it looks like it was like June last year I actually started kicking around some Midi stuff, and basically if you know nothing about it, it's probably worth just quickly going through some of these videos. I also talk about mapping. I think I also talk about in one of these to do with the reason document, because the reason document is actually quite an important, or it's a very powerful section within the mapping area where you can do actually some really whizzy things. So it might be worth just getting yourself aware of that. So before I really kick off big time, just a little bit of background I suppose. I happen to be on Amazon, as you do, and I had some recommendations for some controllers which came up, and some of them were to do with the Akai. In fact, the one which came up was the Mini Mix, I think it is referred to as, and I thought, yeah, that'd be quite good to marry that with the Hamu mod panel, but I thought, no, I've got too many controllers, and I was looking around, and I looked at this, and one of the things that actually caught my attention with this, more than anything, was it's all to do with Ableton, and I don't know anything about Ableton, and I thought, well, what's so special about that? Because it does say it's a Midi controller, but it's saying about Ableton, and I was hoping Ableton didn't have its own kind of protocol or anything. And because sitting on my desk, I have this little LPK, and it's something I use a lot, so I can quickly tinker on it. And so I saw this, it's got some keys on it, it's got a few encoders on it, and it's got all them buttons on it. And I thought, oh, this looks like it's going to be an interesting project. So I wasn't actually out looking for a new controller. I just saw this and thought this could be a really good project. I always wanted to learn Lua, and obviously the codec side of things, and I thought, yeah, this would be an ideal rabbit hole to jump down with this particular device. So the first thing you probably got to do if you're going on the journey is obviously we go to the good old Reason site, and if you scroll right to the very bottom, down at the very bottom you can see one which says developers. Click on the developers, it brings you onto the developer page, and also you can download the Reason SDK if you really wanted to. But at the top there's another option there which says downloads, and then what you want to go for is there it is hidden away, other SDKs, and you want to download this remote file. This happens to be the contents of that remote SDK. The important document in this one is called the Remote Codec Developer. That's the one I had at the very beginning. The Reason Remote Support, that's basically like the device info. So you can go file, export device info. So that's the equivalent of that for all the stock devices in there. Obviously it's got some little templates to have a look at, and it's got some sample code, and they reference this sample code within that documentation. There is also this test program, or a codec test as they call it, which should allow you to fire it up. I had sort of issues using this, so I just went straight to Reason. I've done everything from Reason. There was meant to be a way that you could sort of get some login information out. I couldn't quite get it to work, and within Reason I'll show you a couple of different ways. There's a basic way where you can actually raise an error, and when you raise that error, obviously it crashes the Surface controller, you get a little red thing, but you can really pump out, so you can build up a massive string. I'm talking about, I used to build up 8 or 9 different pages worth of data, so it's do all my variables and all sorts of other things. I pump it all out so I could see exactly what was going on. A very slow and tedious way of doing it, and then a little bit later on I actually come up with a different way where I can actually send login information out on the fly, so I don't have to stop anything. I can actually get some login information coming out, and I can see really what's going on. And it did teach me a lot about how the remotes really, internally, how it all worked, because I didn't have any idea, and it doesn't actually describe it too well in the documentation. The documentation is good, but I had to read that documentation, and the documentation we're talking about is this documentation here, and I really had to read this document. I probably have read it about 15-20 times. The first time I read it, it just went straight over my head, because I'm the sort of hands-on person. I like to be hands-on. I like to get on and actually do things and experiment, because I learn a lot from failures. I expect a lot of other people do. I like to cause errors so I know where my boundaries are. So that's the way I work. Now, I have been a coder for many years, so I came across this little video here, which is, if you've coded in the past, definitely worth having a look at. It's this Lua Crash Course, less than 15 minutes. It is really good, and it does go over lots and lots of things, so I picked up a lot of good information in here. I think the only thing, obviously, I had to really get my head around was the tables and how they manage tables within Lua, because tables are actually a very big thing. And it gets a bit confusing, because when you look on certain websites, they confuse you because they say, hey, there's these array tables and there's another I refer to them as dictionary tables. It's where you can reference them obviously via text, so you don't reference via number. But they are actually both. They can be an array and a dictionary table at the same time. So it's quite weird. So I managed to get my head around that, and once I got my head around that, it meant, yeah, I could really move forward. Very, very quickly at this stage as well, I did hit on a few issues within reason when I was doing my coding, and that's to do with, they refer to them as up values. Basically, you're limited, I think, to something like 60 variables, and obviously, in fact, that number's smaller because Reason itself is obviously running some code which is called in your code, so it's probably got some other variables higher up. So I hit on this limit very, very quickly because obviously I had, you think about it, I had 40 buttons and 8 encoders, several pages. Before you know it, you could be into hundreds of variables. So I actually converted most of my variables into tables. So that's what I use, and that just got around the issue straight away. I still am using a few variables, but I'm mainly using tables as my variables. Something just to bear in mind if you're thinking about you're going to end up doing a big project as well. The other documentation you need to get on, and obviously if you are a beginner, you need to obviously go and find some more videos and obviously learn Lua. This document here was quite obviously, this is the main reference guide to Lua itself. It's very important because in Reason we use 5.1. If you go and say search for Lua reference, it'll come up with like 5.3 or 5.4. It'll come up with different versions. You've got to run the 5.1 so that way you know the commands you're actually looking at and things you're looking at are actually in this particular version. Also, if you went through this particular document, you'd see there's loads of extra commands which don't work. That would be for security reasons. So there's a lot of OS stuff which would have been really handy for me. File functions, so I could have actually written back to the mapping file, but all that's been taken away and excluded, quite rightfully, because if not, someone could easily write a bit of hacking code to go and rip out or do keylogin on your system very easily. All sorts of things could be done. So they've obviously tried to protect us, but then we have to run with these particular limitations, which isn't a problem. I suppose one of the next things we need to think about really is like your editors, what you're going to use, and obviously that's a very, very personal choice. I tend to use Notepad++ for actually doing the mapping side. Not to confuse things too much, I actually store my mappings inside a SQL database, and I can pull the data out, and I actually manipulate a lot of it in Excel, but then Notepad++ is where I sort of do a lot of tidying up, where I do a lot of cleaning up. It's very, very powerful application, especially on the searching and replace side. And that's one of the reasons I like it. I do run the 32-bit version. I have done for many, many years. It could be worth looking at the 64-bit version now. Back in the day when 64-bit came out, because this can have extensions and plugins put onto it, not many people converted them over into the 64 version, so you were limited to what there was. But as I said, that's quite a few years ago, so it's probably supported now. Maybe I should have a look at it, but at the same time, there's nothing wrong with this version. It works perfectly okay for what I need to do with it. For code, I like to use Visual Studio Code. Sorry, I find it weird calling it Visual Studio Code because obviously there was Visual Studio, isn't there? So this is Visual Studio Code, and that's what I like to do it in. Obviously there's extensions for Lua as well, so that means it color codes it for when you're doing the writing. And because 1 minute I could be writing in Lua, then the next minute I could be writing in something like, oh, where are we? Here we go, we've got some VBS in here, and then somewhere else I've got some other code as well, so even a bit of auto hotkey. So I might be switching into something like to do some stuff with auto hotkey. And when you switch language a lot, it's just silly little things. You might be saying, oh, I'm going to write a quick for command, and you end up writing it for the VBS, but you're actually in Lua. Obviously it's not going to work. And so the nice thing about obviously this particular interface is as I start to type for, it will show me what it should be, it show me the format of it. So I go, oh yeah, that's the code I'm writing in. So it's quite helpful. The other program I use heavily for my coding, believe it or not, is good old Excel. I use Excel for doing a lot of formatting of code. So in this particular case, as I say, I have a SQL Server backend, but I'm doing a lot of VBS stuff as well and VBA stuff. What this allows me to do is say, hey, I can list out my table columns. Doesn't matter what I'm talking about there really. But then I can write code which strips them table columns out and uses all these parameters, and then I can actually just copy out these ones and copy these over, and all of a sudden that's all done. And what I find is when I'm writing a lot of replication of code, and you may do, I know when I first started writing out the init section of the codec, that's all to do with items, so you have lots and lots and lots of items. I actually wrote it in Excel because it meant if I decided that I wanted to make one change, I could come in and change one bit of a formula, just copy it down, and it's all done, and I can just then copy that into the proper Lua file which I needed to. So yeah, I find Excel really, really handy for doing repetitive stuff, especially as you can come back and you can quickly change things as well. And they're the main tools that I kind of use. So let's bring it together and put some meat on the bone of what we've been talking about. To start off with, we're going to have to produce ourselves 4 files, which is going to be a LuaCodec file, which is like a control file, a PNG, simple picture for the control services, a Lua file, which is going to be our main code, and we're also going to have obviously a remote map file. 3 of the files are going to reside under the Lua codecs. Where you actually put them in here, it doesn't really matter. It's not the same as the Midi codecs, where you have to be a bit more careful. But I am going to create myself a little folder just to keep things together. And let's call this video, because I'm making a video for you guys. And let's go in here. Now I need to create 2 files in here. I'm just going to create a text document. And we're going to call this one, this be nice and boring, and call this video Lua Codec. So that's going to be a controlling file. It's prompting me, so I'll bring this on the screen once and then I'm just going to leave off the screen. Because I'm changing the file extension, it's just telling me it might become unusable, so you just click yes, bosh. Then I'm going to create another one very, very quickly. And this one, I'm actually going to give this one a little bit of a proper name. Now, if I'm perfectly honest, I would give all my files like roughly the same name. And the only reason I suppose I'm not, it's just more for demonstration purposes more than anything else. So I would sort of call everything the same name. So it's asking me about the extension again, so I'm going to say yes. So as I'm here, I'm just going to click on both of these, right click, and I'm just going to open them in my editor. Cool, let's switch back. And now what I need to do is go into mapping. So let me scroll down here. So we're going to go into mappings. This time I am going to just put it into one of my existing directories. Why not? So I'm going to say new text file again, and I'm going to be boring, and I'm going to call this Fred.remote map. Just as, again, so you can see it can be different names. Ideally, I would like to call that PoohBear, LPK, Lua, whatever else I've called the other ones. Again, it's asking me about the extension, so I'm going to click on that, and I'm going to open it up as well in my editor. Now, before I forget, I need to obviously grab my picture as well. So I've got a picture, I think it's on my PoohBear directory, and let's have a quick look down. I think it's under LPK, there we go. It's just on the screen, you can just about see it, can't you? So I'm going to copy that, and I'm going to put that in my video directory as well. So there we go, paste. Cool. Let's switch back to the main editor, and what I'm interested in is my video LuaCodec. Now, I highly recommend that you actually obviously copy and you paste from other people's code, and then obviously you can populate it up. I'm going to admit this is the second time I've done this video because I wrote it out from scratch, and I found actually I ended up typing more than I was actually talking, and it got a bit confusing. So what you need in this particular file, you have to have the remote support control surfaces. So this is actually going to set up a control surfaces. So the manufacturer name, so this is whatever you're going to want to call it. So I'm going to call mine PoohBear video, as you do. The model I'm going to actually call Tom. So this would be, obviously, again, you need to put a sensible name in here, but again, just for the purposes of this video, I'm just going to give them silly names, so you can see things don't have to quite tie up as much as you think they do. Now, I've got a picture already set up, so this is obviously, I've got to obviously put this in correctly, so I think I called that a Lua.png file, yeah. And the source, so that was the file we just created a second ago, which is going to be called PoohBear LPK Lua. So that's the one we just created in that directory. Now, descriptions. These are to do with your MIDI ports. So these come up in the control services. I'll show you in a second exactly what we're doing. And for now, again, I'm going to put in here rubbish. What I do tend to put in here, though, is the actual MIDI port of the controller I am dealing with. So in this particular case, it's the LPK25, and that is the actual port name. So in the description, I put LPK25. So it reminds me that when I'm setting it up, that should be the port. Now, is this optional? No, it's not optional, so it's false. So that means we've got to have an import, which obviously makes sense. What's the point of setting these things up? Outports, or MIDI, this is for MIDI out, don't have to have an output port. So again, like my LPK, there's no returning port on it. It doesn't do anything. It's just a keyboard. It's very, very, very basic stuff. So I'm just going to, in here, say another port name or something like that. Let's call it that. I don't know. And this optional, yes, it's optional. So I don't really need it. Let's get rid of that. Down here, has keyboard. Yes, it's a keyboard. Quite straightforward. And now we've got ourselves some setup text. Now, this setup text can be written a couple of different ways. So in here I could go hello world, and then here I could sort of do some escape characters. So this is like doing a carriage return. How are you today? And again, let's do another carriage return, and I could then say, I hope you are well. Boom. And that will also appear in the control surfaces. As I said, in a second, we'll actually have a look at it. Now, there's a different way you can actually write this, and this is my preferred method. So, I admit that's kind of clean from a coding point of view, but it's also, I find it messy from a formatting point of view. I find this other way a lot easier to write. Fortunately, it's already put them in. I'm then going to hit enter, and I'm actually going to go back to the very start of the line. And this is where I like this, because I can now format it without having to have any escape characters, and I could actually put that there if I wanted to. Now, as I say, I like writing it like this because obviously if you've got loads and loads of text, it's just a lot easier to manage and to do the formatting. As I say, from a coding point of view, it might look a little bit messy, but it's only these little bits, and that's why I like it. Let's actually have a look at what we've actually produced here. Under the manufacturer, here I got PoohBear video, so manufacturer PoohBear video. It's automatically going to come up with Tom, because there's only one entry, because obviously there's more entries that appear. So there's my Tom. Here's my hello world, that's my message, hello world space, how are you today, so on and so forth. And down here, that's my goodbye world. As I said, usually what I've put in there would be something like LPK 25, and what I usually would put on here is obviously either the same port as above, or I put the port name in again, or in this particular case, I'm actually going to put in there something like not used, because I'm not actually using it. So it's going to switch back to that. So that's what these two here. So obviously here, as I say, and there is my real MIDI port for that particular controller. And so that's really what we've been setting up here with the LuaCodec, as I say, is the control inside. Please note, I was using a little bit of PoohBear magic to actually show you that. That won't actually work for you until you've actually got your Lua and you've got your remote code, your remote set up and everything else. If not, you're going to start getting errors. So this is going to be our main Lua file. So in the Lua file, you do need to have what's called a remote init. This is where we can define our items and set our inputs and our outputs as well. This isn't standard, having manufacturer model. I always put this in because I like to use that. This particular case, manufacturer, if I was to run this, will come back as PoohBear video, and the model will be Tom. Because a LuaCodec file, which I mentioned, can have many, many entries pointing to many different Lua files, which is something I've done, like with my eRace, that's an MPC controller, so I've quite a few setups in there. Most people, and again, if you go through code, you're going to see local items, and we're creating ourselves a table here, will be written more like this. And you're going to see in between the two sections things like this particular thing here, which says name, keyboard, boom, 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 comma, and then it'd be that bit there. Now I do mine differently. I do what's called a table insert. So I create a table, and on items, I do a table insert, but obviously on inputs, I can just write it per normal. Now the reason I do table inserts is because later on, if you're not doing what's called auto inputs, and you're controlling it and you're manipulating it all yourself. So with my main APC controller, I was manipulating so much code in the background, I have to track the item index numbers, and I have over 6,000 items set up for that APC. But that's mainly to do with the parameters, and I can talk about that another day. So I use a table insert, and then what I could do if I wanted to, obviously it won't be called my var, it'd be called a proper name, but say, hey, I'm going to have my var, and I can do something called hash items, and that hash items in this particular case will equal 1 because there's my insert. If I've done it again under this one, it'll equal 2. But as I say, because I've got 6,000, it starts to make sense why I'm starting to track them. So I've got into the habit of this is how I do my items. Now if we look at the items, the name can be anything you want, but this name is tied into this name down here. So this is tying into the input. So you can think of items as, I think of it as like a middle stepping stone. So our inputs is really where we should start, but everyone writes it as items and then inputs. So the reason I say the inputs is where I would start, because this is the MIDI keyboard. This is my MIDI keyboard coming in. This is either, and this is obviously looking at it in bits. So we're either looking for an 80 or a 90, or we could even be looking at a note on with 0 velocity as well. So that's what we're actually looking for there. And we're going to push it onto that stepping stone, what I refer to as, called keyboard. And the same, this pattern here is looking obviously for a CC number. Question mark basically means a wildcard, so it's looking for any MIDI channel. So if I was to put a 0 in there, that would be MIDI channel 1. So you've got to remember you've got to offset everything by 1. So F will be MIDI channel 16, which in obviously hex is 15. But by using that, it's listening on all MIDI channels. 40, that's the hex 40, which will be 64 in decimal world, and 64 is used for sustain pedals, or as Reason likes to call them, damper pedals. And XX will be the value which is going to be returned. Up the top, you can actually specify these values inside here, but you don't have to. So as default, X is going to go to what's called a value, which is a note on or off. Y is going to go to the note, and Z is going to go to the velocity. So that's set up by default. So hopefully that's quite straightforward of really what we're looking at. So we're creating ourselves a name. Oh, the inputs. So we've got to tell it what kind of input it is. So this is a keyboard. This happens to be a value. So what you find is things like your faders or your knobs will be a value. If you've got like an encoder, that comes down as what's called a delta, because deltas have to be handled a little bit special, because in Reason, Reason's looking for a positive or a negative value, but deltas are sent out as a positive value only. So we have to manipulate that afterwards, i.e. on one of my controllers, it's really nice, it sends out 64. So anything above 64 means I'm actually turning my knob to the left, and anything below 64 I'm turning my knob to the right. That's easy to manipulate because I can bring it into here as a delta, and I can just, for the value when we're down here, I can just minus 64 of it, and now I'm back at 0. So 64 now is saying 0, but obviously if I turn it the opposite way, I'm getting my negative values, what I need. So yeah, so some of them you need to do a little bit of a special setup. The other input value, I'm not sure if I said, you've got a button, so you've got button, value, delta, keyboard, and there's another one which I've never used, and I can't think of it off the top of my head. I think it's something like no input or something. It's to do with displays, but I've never actually used that. Right, let's calm down, not get too waffly. So yeah, so we have to define the items, bush, then we define the auto inputs, and these are what are called auto inputs. So this will work on its own, whereas later on we're going to be getting into some extra code where we're actually going to be managing the actual inputs and what's going on with the inputs, so we take total control. Auto inputs are meant to be really, really, really fast and efficient. So we need ourselves a mapping file. The important bit of this mapping file is the manufacturer name. It has to be absolutely precise, including case sensitivity, if I remember rightly, and same for the model. Mapping files between Midi codecs and Lua codecs are the same files. This is where we've set up our keyboard, and this here keyboard, that's the statement which we had in our Lua file, and the same with dampen the pedal. So if in that Lua file under items I decided to call that Fred, then the auto input I'd name it Fred. Here I put the word Fred in, and this is actually the keyboard, so this is where it's actually talking to the actual device. So it'll actually send the notes to the device, or in this case it could send the damper pedal, the result of the damper pedal to the device. Now this is actually called the master keyboard section, which is obviously slightly different. We can have other scopes as well, and there's a hierarchy. So if you've actually got your main scope, that's above the master scope, and there's also a document scope as well. So you can stack things and overwrite things, I suppose. That's effectively what I'm saying. So I could have it in here, map up one of my buttons out to do something, but later on in my other scope, I might say, oh, I want to use that button, I can use it, and this one would be ignored. So it's just a hierarchy of things, but let's not get too confused, or let me not confuse you too much. So yeah, so this is a basic mapping file. The formatting is quite important. Now before I actually move on, as I said, this is the second time I've gone through this. I wrote everything out by hand the first time, and I actually made 3 kind of silly mistakes. What I'm going to do is I'm actually going to play them mistakes. I find I learn more from mistakes, as I said earlier. I like to cause or deliberately do things to try and push the boundaries so I can work out not just a black and white case in the book where it says, oh, you can do this. I like to really prove it and push things. And so yes, I've got 3 silly little mistakes I made, and the great thing about these 3 little mistakes is they actually pop up in 3 different areas. So you yourself, if you made a mistake, hopefully I'm going to give you some pointers where you could maybe go and look, and so you can see maybe where them issues are. So let's have a quick look at our preferences. Let's bring that into screenshot, into MIDI, and then what we need to do is, oh, hang on a second. So down the bottom here, it will actually tell you if you've got any errors, and I've actually got an error. Let's have a look and see what I've done wrong. Whoops. Failed to run. Oh, I've got an issue with my LuaCodec. Oh, okay, so that's my bad. I honestly thought it might have actually picked that picture up, but obviously the picture has to be in the same directory that I've actually got my LuaCodec file. So that happened to be in a directory video. So what I'm going to quickly do is I'm going to copy that over, my picture, into that folder, and then we can restart Reason and get it working. MIDI. And as you can see, no errors at the bottom this time, so let's go add manually, pull that into view. Now let's choose the drop down, and as you can see, we've got one here now called PoohBear Video, so we can click on that. Here's our Tom, and we've actually got an issue this time again, it can't find our remote map. So that's a good chance, as I said to you before, that's like probably a spelling mistake. So it's quite good that we've got these errors coming up. So let's go back. I'm going to go into my video codec and go, right, what have I called this? I've called this manufacturer PoohBear Video. So let's just do a copy there. Boom, boom, boom. Definitely says Tom. Okay. All looks good to me. So quickly switch back to the actual mappings itself. Oh, there you go. I missed out the H. Oh my God, I can't believe that. That's why I say do a copy and paste and you can't really go wrong. Or theoretically, you shouldn't be able to go wrong. So let's restart Reason yet again. So I've restarted Reason, so hopefully this time, PoohBear Video, Tom, here we go. Hello world, how are you today? Hope you're well. So there's all our code, there's everything else. I say that's our MIDI there, so I can click on the down arrow and I can choose my MIDI port. There's my MIDI port, I'm going to click OK. Boom, 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 boom. Oh, we've got ourselves another error, and this time, okay, it's a Lua error, so that's actually obviously going to be the actual Lua file itself. It's even telling me the line number 9, attempting to call a global name, a null value. Oh, that's a bit worrying, that one. Let's have a quick look at that. Probably something very straightforward. And here we go, there's the actual Lua file, number 9, here we go, name. Okay, I've missed out an equal sign. It's so hard to write this stuff when I'm on dual monitors doing things and recording at the same time. Of course I'm going to make mistakes, but it's good I'm making mistakes. At least you're going to see, you can see how the errors are coming up and how to fix them. Okay, I'm just going to click OK, and I think you're fine because I've actually got the file already loaded. There we go, I can just restart it and it's actually worked. So we are actually up and running, and I suppose the final proof in the pudding would be to say grab something like this one. Let's put it over here so you can see it. There we go, friendly keys, and I'm now going to play. Hey, just played a couple of notes from my LPK, so we're actually up and running. Oh, so there's the basics. So let's look at something that isn't in the manual, and that's to do really with logging or /debugging, because at the moment, inside Reason, I find the codec is quite a blind system. Obviously, if you're running Lua outside and actually inside this environment, we could do print statements, we could actually see what's going on, we could actually have a look at the variables on the fly. But at the moment, we can't do any of that, so we need to get some information out. So let's actually look at how we can do that. So, very basic one, and let's actually go straight away for our hello world. Here we go, hello world. Great. Going to do a save. We're going to start up our Surface controller, and it errors. And let's grab that error across, and as you can see, it says hello world. So there we go, we've got ourselves a very basic piece of information. So let's move this forward very quickly. And I'm going to actually put in here the word output. And the reason I'm going to put the word output in here is because I'm actually going to create myself a little variable at the top called output. And let's actually pump in a big bit of data. That will do. Let's do a save. Pull this up, restart, get the error, bring it across. As you can see, it's absolutely massive. So what I'm going to do this time, I'm just going to say copy that, and I'm going to go and put that onto a clipboard, or sorry, a notepad, should I say. And that's the result we've actually got out of it. And obviously we can have pages and pages and pages. So let's take this another step. There we go. let's come down here. So what I will tend to do is I do an escape character /n, so that's a carriage return. Then I'm actually going to write myself a simple little function, and I'm going to call this function log, and I'm going to pass it some text parameter. So I'm going to say output equals output, and we're going to concatenate text together, and we're also going to slap on a carriage return at the end, and that will now allow me to do things as simple as log, and let's go for hello world, and I can straight away do another log, and let's go for how are you today. Something simple like that. Control S, bring it up, preferences, start it. It's going to give an error, click on the actual error, bring this across, we have to put it into clipboard, and there we are. Hello world, how are you today? And so the first one with the carriage return, you notice it's not all muddled up with that first top line now. So it's on its own little line, so we can do a bit more formatting. And obviously with that log statement, we can shove that log statement all over the place. So you can go log, 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 and then at some point you're going to output it. I think what we need to do now is actually move this way forward and get some real proper nice information out. Let's go for that. I've got this little bit of a function. I've picked this up from Cat Black, and basically all it's going to do, because tables can hold tables as well as values, and tables and values and tables and values, it's very nested. This will just flatten it out, puts it into one output file, and then obviously we can output that, because in a minute we're going to be using some functions which are actually in the codec manual to actually go and retrieve some data, so we can actually look at proper data, what I refer to as proper data. Right, so to do that, what we've got to do is we're going to have to create ourselves a couple of items. So I'm just going to quickly just throw these two items in to start with, and this is going to be called param1, and this is going to be called param2. And what I've done is I've actually updated my mapping file, and I need to put in here output. Yeah, I need a value, don't I? So I need to get myself a value. Cool. And so I was going to copy that, paste that down here. Boom, 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 cool. And I'm actually going to do, in fact, I'm going to do one more, but I don't need half this data, because the other output we got is something called text. So I'm going to output some text. There's no input value, so I'm going to remove that, and I'm going to call this device name. That's a name which I've decided to call it, so it's not a special name or anything like that. So cool, we've got some parameters. Very quickly, this is what it looks like. So this is a simple little scope for Europa. There we go, device name, call it Europa. Oh, I've actually given it some modes, so let's actually go and put the modes in as well. I thought I'd put a mode in, because then you can actually see how that works, and obviously modes are something which are, I won't say important, but modes are useful in mappings. And I think I need an equal sign there, don't I? I'm going a little bit mad, there we go. So that should all work there for starters. Now we've obviously got to get that output, but the problem is we can't put the code anywhere here, and we can't put the code in here. Why? Because it's all got to initialize before we can actually do anything. So there's another function which is this is actually in the book, in the manual, called remote process MIDI. So we're going to remote process the MIDI. It passes it an event, so an event will actually be the MIDI which is called in this. This is always called whenever I'm change anything on my controller. It comes in here and it's passed as an event. So if I push a button, move a knob, even play my keys, it can come in here as an event, and we can obviously manipulate it. At the moment, I don't care what MIDI event we're going to call it, because what I'm actually going to do is once we run this, it won't error out until I actually press a note on my keyboard. So this item is going to relate to this item, so I've actually got to take away the local to make it a bit more global so we can actually get to it. And now what I'm going to say is I'm going to log, and let's keep this straightforward to start with. So I'm going to call that new function which we put in, called table, and what I'm actually going to pass it, there's another function which is called remote.get item state, and then what we've got to do is pass it the actual index number for the items. That's why earlier, remember I was saying I'll have my varchar equals hash items, so you could, in the end this will start building up, so you need to sort of find or know how to reference them. I'm actually going to pull every single one out, so it doesn't matter, but that's why I reference that data. So now we've actually pulled all the, we're going to build ourselves little tables, boom, 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 we logged it out, so we need to do, say, error, and obviously we need our output. So we'll save this, so let's go and grab preferences, restart this. As you can see, we don't get an error, and now I'm going to hit a note on my keyboard which will cause ourselves an error. Let's have a quick look and see what we got. Now I've actually made another little mistake, so let me grab my notepad, and as you can see in here, well, nothing's really set. You see it's all coming back blank, so it's actually not very helpful at all. And the reason that's all coming back blank is because to get outputs we've got to set the MIDI out port, and I happen to have a spare port here called LuaCodec, so I'm going to just throw it into that. So now it's reset it, I'm going to hit the key, we're going to get an error, we're going to go back into the log, I'm going to copy that to clipboard. Let's have a look at what we've got here, and hopefully this time what you're going to look at, we've got ourselves a lot more decent information. So the first two are going to be rubbish because that's to do with the damper pedal and the keyboard, which are no good. So this one's a bit more handy. As you can see, we've got some more reference to the attack, to the release, and then down here, this was the device name. So there's Europa. Obviously the formatting is really, really wrong on this, so I would actually say, hey, let's try and tidy up the formatting and try and make this look a little bit neater. So to make it a little bit neater, just above it, I just put in a line, which I'm going to say log. I'm going to start off with a couple of carriage returns. So we want to get rid of some carriage returns. And let's actually say, well, what item number are we actually talking about? And so let's, so I'm trying to put a dot in there. What's going wrong? There we go. And so what are we talking about? So this is going to be our index, so that's going to be the index key there. And then, what is the name? So let's pull out the name. Name equals value.name, shouldn't I? I think that should work. Restart, hit a note, boom, bring that, clipboard, bring up notepad, and as you can see, we've got things that look a lot nicer. So it tells you that's the keyboard, the damper pedal, parameter 1, parameter 2, and here's our index numbers, item, and I've said item number. This is really the index of the item number. So we're now getting some proper information out, which we can obviously start working on, because this is a case of saying, oh, I thought I set a number, have I really set it, what's going on? So actually, let's actually have a look at my login system. Now, I've already stated that reason, or our Lua, our codec, we cannot write out to the OS, we can't write out to the file system, which is a shame, and we can't even write to a basic screen or anything. However, we stop to think about what we're doing. We're taking MIDI, we're sending that obviously into Reason to change some controls, or I can use my mouse, change some controls, and that actually comes back with eyes to the codec, and we send that back out to the controller. But there you go. I'm saying it. MIDI, at the end of the day, all it is a simple messaging system. It's a 40-year-old plus messaging system, and we can just piggyback onto it, and get Reason to do the donkey work for us. And that's exactly what I've done. So this is a very simple idea, and as I always say, simple ideas I think are clever ideas, so it's quite a clever idea what I've done here. So all I've got here, and what we're actually looking at this particular screen, this is a simple VBS script which is running, and that VBS script happens to be calling a COM object, and that COM object is talking to Midi-ox, and Midi-ox inside of Windows is a way that we can reroute a lot of our MIDI ports, and in this particular case I can intercept MIDI data and I can manipulate it. This first top bit actually is data I'm getting from Midi-ox. I go and double check to see what ports I've got and all the rest of it, and there's some other bits here which I'm controlling, but this here is actually come from Reason. So this here, PoohBear, Akai, APC, and what it's actually doing, so there's me, I've actually just moved a knob or something, so I'm getting that data out. Like here, I've got like a transfer Morphix color, so I probably was touching on the Morphix side of things. That's calling another routine, which is now calling another routine, so I try and stack up the routines so I can say, well, who's called what, and it just helps me sort of track what's going on. So so my functions can call a function, and I try and say to them, hey, I've been called from here, If not, it gets a bit confusing. I'll probably made that sound confusing myself. So it's all straightforward, and this is actually live. This is actually live. I know I'm looking back through the log. Here, I'm sending some keys from the keyboard. So underneath my desk, I've got my little MIDI controller, my FCB 1010, and I can, when I hit a pedal, I actually convert the pedal. The MIDI goes out, comes into here. This actually converts it into keystrokes. I send out keystrokes. I have auto hotkey, which actually then intercepts this, and then might pass it back to Reason to say, hey, go and switch the rack around to the back, or go and open up the browser. I use it for zooming in and out, so I use Reason Zooms. I've got a pedal underneath where I zoom from 100% to 200% and then back again, every time I hit it. So you can do all sorts of funny things. So at the moment, I'm going to hit a control on my other keyboard. There we go. Let's hit it again. Move to a different device, which I've only got one device actually set up in Reason at the moment, which happens to be Europa. It's told me it's actually an on-the-fly mapping, bomb, 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 and I'm actually on the main page and that kind of thing. You can get quite good information from the login. I mainly use it to make sure things are being called when I think they truly should be called, because you're in a blind, as I said before, it's quite a blind system, and without having any login, it can be very confusing. So let's actually crack on with how this really does work. And there's quite a few steps to it, so it's not just a simple thing to say, hey, we're going to just set this up and off we go. I'm going to be copying over a number of, a variable, some tables, and some of my own functions. So I'll quickly go through them, what they actually are and what they really are doing. Who am I? To be honest, this is usually a placeholder, and what I'd actually go and do within the remote init, I'll actually set that up properly, and I drag out that manufacturer and the model, and I can concatenate that together, and I actually build a proper who am I. So it'll come out something similar to this, like this. Here's my PoohBear, my ERA, normal channel 14, and you can see these are all talking on different channels, or here's my APC. So this has actually been set by the remote ini, and that sets a simple variable called who am I. Login, my little login table, it holds a level. The whole point of login, I will admit, I think once I started using this login, I changed the way I was going to use it. Because you can get live information out, all of a sudden I was like, this log 1 and log 2 is equivalent of the output, so you could actually store strings. That's the whole principle behind it. I never use it. The counter I do use, I thought I have a counter rather than a timer, because again on my output, if you may not have noticed, there's actually a number which it's a counter which counts up. I could have had that as a date and a time, but because sometimes you really are spitting a lot of information out, I find it nicer to actually see the counter going up, because you might be pumping out at the same time until you start going down into nanoseconds and things, and it starts to get a bit silly. So I prefer a counter, and that's what that counter's for. And the level, I had this idea, which still works, and I still kind of use it, where stuff which is really important, which needs to be outputted to the screen, I make like a level 1. Stuff which is less important, I can make a level 5, and you'll actually see that I'll actually call a function called Sendlog, and I'll pass it a level. By default, if I don't pass it a level, it's like level 5. But as I say, what tends to happen is I debug something, I'm happy, I just remove the Sendlog out. I don't leave it there. There's only a few circumstances I have left it there, because obviously that information could be important to me. MIDI stuff to do is quite an important table. This is a table which I can put in my MIDI messages, which we're going to see in a minute, and then that is actually passed to a routine which is actually in that codec document, which I haven't actually spoken about yet, which is called Remote Delivery MIDI, and we'll talk about that a lot later. So some basic functions. This is just a simple hex converter, so if I was to put in the number 10, it'll actually give it back as a formatted 0A, so I'm always looking for the 2-digit returns. Straightforward string to hex, so if I say to give it the word hello, it'll actually return it, like 5 hex numbers back. And that sort of result will look something similar to this. So here's like a sys message. So here's all my hexadecimal. So I convert it to that so I can send it in the MIDI world. Then we can also reverse that and do a hex to string. So we can actually convert that back if we want. This simple modulo function was written because it was stated that modulo didn't actually work in Reason. I've tested it and it does. But I've left this modulo, I got this from, I think it was Cat Black, and I've actually even discovered another way of doing it as well. But I left it in because I thought, well, what happens if I do decide to run this on old versions of Reason? So I thought, wow, if modulo wasn't working in a previous version, well, I might as well keep this in so we know it does work. Print table, you already know about because we've actually gone over that. Get item, well, that's something which is nice and basic, a bit similar to how we're doing our formatting. So it does a bit of formatting for me, putting out my item number, the name, and then it actually does the print, calls the print table. So it just means I can just have a simple function where I can pass it a key and it can go and get my information. Now here's probably one of the more important ones, which is the SendSysX. This is actually doing the actual work of actually sending out that message. Quite straightforward. I pass it a text parameter and I can pass it a number, or as you can see, I'm actually handling it if I don't pass it anything. Basically, if I don't pass it anything, it's going to actually go and send the message out and it's going to go to screen. I've got a choice. I can obviously pass it a clip of 1, which means it'll go to the clipboard. That's why it's called clip. And then I decided, hey, I might want to wish to log out to a file, so I can actually log out to a file and it's a predetermined name. The only other sort of key things which are really happening within this particular function is the fact that your MIDI message could be really, really, really long. And in Windows, I think I was looking at it, it handles like a 1K message. So I decided to chop it up at every 750 bytes. So this is something maybe on a Mac, if you're playing with, you might need to check out, and you can either make it bigger or smaller, or just leave it how it is. So yeah, so that's all that's doing. It's just doing a quick bit of working out how long is the message, do we need to chop it up? And then this is the table insert, or this is my MIDI stuff to do. As I mentioned, this is actually where I can put MIDI messages, and we use a function called Remote Make MIDI, and there's the message. That message is obviously here. So I've actually taken the manufacturer's ID, made it a system message, decided, you know, is it going to go to screen, clipboard, or the file? Then I call my string to hex, so that's where I might pass the word hello in that text, so it'll actually come back. In fact, let's be honest, if it's hello, it wouldn't be running this little while loop. It'll actually jump straight down to here and actually push it into this bit here. But that's the basics though. It'll actually go off, and you can see this bit here and this bit here are the same as this one here and this one here. The only difference is the end string. So if I end my string in a 7E, that's me saying, hey, there's more information to come. So when I send this out, at the other end, I say I've got a script which will pick this up and say, oh, is it 7E? I'm going to wait until I get some more information in until I hit my 7F, which means that's the end. Then I'm ready to push that out to the screen. So it pushes the text out all in one go. The remote, as I said, the Remote Make MIDI, that's actually in the codec document, so you can also go and look it up. The messages actually can be very, very simple. So for example, this may look like a bit of a messy one, but a simple message could even be something like send something out on channel 7, and I'm actually sending out a note on. So let's actually send out the very, very first note, and that's my velocity level. That's it. That's a simple MIDI message to send a note on, note value. So obviously that could be a different note there. So let's pick something like note number 64, something like that. And I say this is the velocity which we're actually going to be sending out. This is my actual send log, so this is really where I throw this all over the place. And the send log is just taking in what I refer to as my process. So in places you see, whenever I build a function, I build up a local process and I give it the function name in brackets. So again, as I said, this will come out in this sort of log here. So there's my remote ini. So it's telling me where it's actually being called from. So that's all I do that for. It's just a tracking, something for tracking. Text is the actual text I wish to send out. So that could be like the hello, the level. As I said, this can be a level from 0 to 5 really. Default is 5. And basically, as I say, I've on my controller, I can go in and actually set different levels actually in the controller to say what am I outputting to screen. Most of the time I just leave it as 5. I've debugged something and I've removed the send log. So I put the send log in, do it, and then I'll remove it. Simple counter, so as I said before, I'm not using any timers, I'm just using a very, very simple counter. You can see what we're actually sending out here. And in fact, this is actually an old way I send it out. It doesn't matter, it's a similar sort of thing. Who am I? What's the process? Then what's the text? And the 0 is obviously saying output to screen. The reason I say it's an old one because I actually now do who am I, then I do my counter, then I do my process. So I've just literally swapped it around from my other stuff. I obviously was playing with this and I decided that was better in the middle, so this didn't move. Because obviously when numbers go up, the formatting changes, and actually I preferred this being nice and straight so I could see really easily who was actually sending the message out. So let's get this copied across into our PoohBear Lua we've been building. One of the other really key functions which we haven't spoken about is the actual remote delivery MIDI. This is a function that's called every few seconds by reason, it's polled. The important thing is it returns a table, and that table contains all our MIDI messages. Now the way I decided to do it was a little bit different because I didn't know if anything was multi-threaded or not, so I was trying to handle multi-threaded. So this here is really an old piece of code which I should really revisit and say, well, I now know it's not multi-threaded. In fact, I've actually got a bit of code in there, and that's probably what I should do, is pass the table across, then empty it out, and then off we go. But I have this silly little while loop because I said I wasn't sure of it. It's multi-threaded and it's an old bit of code, but it works fine. So basically, I've populated my MIDI stuff to do with my MIDI message. So that's from my Sendlog. I basically come along and say, don't forget, this routine is automatically called every few seconds. So I have to say, is there anything to do? If there's nothing to do, then we just drop out. And that table is just going to return empty. And that's the way that works. But obviously, if there is something to do, I go and take it, I add it into my proper MIDI stuff, then I remove that line and I keep doing it. As I said, I was working on the principle, I didn't know if it's multi-threaded or not. You've got to remember, this is all new to me when I was actually writing this. And that is more or less it. So we can now call our Sendlog, which calls our sysx function. That will actually stuff the MIDI message in the MIDI stuff to do. This is automatically polled by reason. We then stuff it into another table and we return that table back to reason. And reason itself then will actually take the messages and actually send the messages out for us. So that's all that's doing there. So far so good. We've got all this going. We can't don't write to something like an output, or be careful if you're using something like an output. So if in here, what I'm going to do is to run this, is I'm going to use the word Sendlog remote. So where are we coming from? We're coming from remote process MIDI, so that's where we're coming from. Cool. Now we want our actual message. If I said output, just say for example, what we're doing here, when you actually think about what we're doing, we're coming along, we're going to add this to our output, that's fine. We're then going to add this to our output log, boom, 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 and then we're not going to have this here. So in fact, I'll just delete it, there we go. And then we're going to send it out. This is in the process MIDI event. With the error out, the program stopped. It wasn't a problem, we just stopped. What's going to happen here though is, I'm going to press a key down on my keyboard, it's going to send this, I'm going to release my key, and it's going to send it again, but it's not going to just send it again, it will double it up. So the first key press is going to send out all that state information, which we saw before, it's to do with the keyboard, damper pedal, parameter 1, parameter 2, and the device name. The second time round, well, output's already got that data in there, and it's going to add it to it. So you're going to see it twice, and then it's going to output it. And then if I hit another key, it's going to be 3 times, and then when I release the key, it'll be 4 times. So this output's going to get bigger and bigger and bigger. Obviously, one way to resolve that would be outside of here, would be to say output equals something like, I'd do something like that, to say, hey, let's just put the carriage return in. So that will now make it once only. But as I say, we don't actually even have to store the data anymore. I mean, that's the beautiful thing about it. So we don't need this, we don't need that anymore. We can just come here, and remember I said I had that little special simple routine called get item, and it needs a key. And in this particular case, we're using index, so we can grab the index and we can pass it to that, and that should send it out. We still haven't finished. As I say, there's a few little steps to set this up. From a coding point of view, let me have a quick look, make sure I haven't missed anything out. It should be enough to work. And in fact, I am going to say to you, let's go ahead and send this out. We should restart. So I'm just going to quickly hit a key. And as you can see, instantly, we've got the data, and we got it twice. This is where we can get into the problems of, because I'm pressing my hand down, so we get to see it, and then when I release it, you get to see it again. So that's something to bear in mind. Let me just do something like this on another keyboard, then we can scroll back to that point. You can say keyboard, that, param 1, param 2, device name. So that's why I said it was bad to put it in, but the point is, it's working. That's the key thing. Are we working? Yes, we're working. Tick. Where we've got it is in a bad place. where are we? So we're down in our MIDI events. So this is actually a bad place. Now there's obviously all kinds of things I could do. Obviously something like with my APC key 25, I've got loads and loads of buttons, so I can actually go and obviously look for a particular button or something like that. With this particular controller, I might say, because this is my little LPK controller, I might even say, well, let's actually look for, if I hold the sustain button down. So I could actually write in here and say, only when I held the sustain button down do I actually send that log out. So actually, let's do that. Let's get rid of that, because that's an old hat. Let's actually write something. So what we're going to find here is we're going to look for a matched string. There's a function called remote.matched. Oh, it's not coming up. I was hoping it's going to come up. Match MIDI, isn't it? I think it's called. There we go, match MIDI. And it's just a box standard kind of MIDI string we're going to put in here now. So B's for CC numbers. Question mark's going to be anything. I could put in here 40, because 40 is going to be 64. So, because we're going to look at our sustain pedal. And we're going to bring back another, we don't care what the other value is, which is going to be XX. And where we're going to get this from, well, we're past it, the event. So the events come in, we're looking for the event, and we're going to say, does it match? Now, what I tend to do here, I won't put 40 in here, I'll put ZZ. Because don't forget, we could be capturing loads of CC numbers. Then the next stage is to say, right, we can simply say, does matched equal or not equal to null? So we say, not equal to null, and if it's not equal to null, then we're going to actually run a little bit of code. And in fact, I'm going to come here and I'm actually going to say, we've also got another statement which we can now say matched.z, because this is what that's going to hold, because there's our variable. So we've actually passed it across. So I can say match.z, if that equals, and I need an if statement, sorry, I'm getting ahead of myself. If match.z equals, and because it's Lua, it's a double equal sign. These are the little simple things I've got to remember, and this is going to be a decimal number. So 40 will be the hex number. This has come back in decimal already, so we're going to look for that. And then what I'm going to do here, the formatting, I'm just going to hit return a couple of days turns, because I like everything to be nice and neat, because again, as I said, these routines get absolutely massive. I would sometimes, again on here, say, well, what if it's a real long routine? I'd actually, after this end, I'd say, oh yeah, this was 64. So I just know instantly, yeah, that's what I was doing. Now, that should kind of work if matched equals 64. We could even go one step further and say, and match.x is greater than 0, right? So it's now going to say, when I push the button down only, are we going to produce this log? Because at the moment, if I push the button down, it produces a log. If I release the button, the sustain button, it will produce a log as well. So that should actually stop it. So I'm going to go save. So let's quickly save that. Let's come back to here. Let's go and restart this. Bomb, bomb, it said. And now we need our login up. Go to the end. I'm just going to push some keys on a different keyboard, just so we can see it saying something different. And then if I held my sustain button, there's my device, round 1, and I'm going to let go, and hopefully nothing else happens. So there we go. So that's now tied to my sustain button. I have to push it down and I get it, and when I release it, it's not repeating the information. So that's actually working quite nicely now. So that's the kind of thing we'll actually do to capture our controls which are coming in. Again, something like Midi-ox, and is it called Snooze or some funny name you've got in the Mac, you can actually use to sort of sniff your MIDI data. So you use Midi-ox, you push your controller to Midi-ox, you start moving all your controls, so you can actually write down, hey, what is this CC number, what is this, what's that. The interesting thing about, say, my APC was when I actually started playing with all the buttons, obviously the knobs are actually CCs, but all the buttons and everything, they're just note on, note off messages. That's all they were. All the buttons. And that includes the track and the scene buttons. It was a total surprise to me. I was expecting them to be all CC numbers, but they weren't. They're actually note on, note off messages. Yeah, it doesn't matter. We can use that in exactly the same way. The only difference is I won't be using that particular command there. I'll be using a slightly different command. If I was going for note on, note off, I'll probably use something like, I'll probably do something like that. and then that would probably become YY off the top of my head. So that's actually looking for 90 or 80, which will be either a note on or a note off message, and then we can obviously look for Y. Now it could be that you have a keyboard which doesn't really do a note off, so it's looking at the velocity. Velocity 0 would be equivalent of note off, so you've got to take that sort of thing into account. But it's that kind of simple how we can actually start building all these strings up. I say that could be 0, so I could say B0. That should still work for me because I know my keyboard is actually sending out on channel 1. I can also go and grab this here and go, right, if I hit a key again, there we go, it's still working. So I'm specifically saying you're listening on channel 1, which is 0 in the programming world. It's all offset by 1. So there we go. So this is, so obviously I'm sending that. That is obviously coming up and passing that over to my sysx routine, which is pushing the data actually into this particular table here. Then at a set state, this is actually called, this one here is called, and it's now being pumped out. In fact, you know, and this is how you can learn things as well. So I could say here, Sendlog, not exactly the best place to put it, but I'm gonna say test only, and this is going to be MIDI stuff. There we go, let's say MIDI stuff. Hey. And what am I going to pump out? I suppose ideally I could do with some kind of counter, but I'm just going to pump out hello. There we go. So if I do a save now and I'm going to restart, got to take control of this because it's going to go absolutely mad. So let's grab that up. So when I restart this, he says, you can see, you know, that's how often that routine is being called. And it's only by using things like the Sendlog did I start to learn, oh yeah, that's constantly being called. Okay, this is being called, that's being called. So you end up making sure that anything you put in that function, it makes sense that you only work on it if you really need to work on it. So like here, I'm saying, well, if there's nothing in this table, it doesn't do anything. So it's doing a simple check. It's saying, hey, we're going to create this table, nothing to do, we just return. But obviously we do need to do some stuff when we do add something in there, and it happens to be that we are populating it every single time by using this Sendlog in this particular example. I say, even though I don't have that, if I don't have that Sendlog in there, that's how often that routine's actually being called. You just don't see it. Yeah. So you're being blind. You don't know that this is how often this routine's being called. So if I turn it back on again, so I'm turning it back on from preferences, just turn it on there. So it's on another screen at the moment. And also I can turn it off, boom, boom, boom. And of course, every time I turn it back on and off again, it's starting at 1 because that's how my counters work. They'll start at 1 and all the rest of it. And if you notice, it says utils. So I never actually updated. So that's my bad. So I'm going to quickly whiz up to the top and go, hey, this is who am I? Who am I? As I say, I would use a string here, which would look like something like this. So who am I? Manufacturer ... And so I just pull out the manufacturer model, and when I put it into brackets as well, so that should now work. So I can go save. Let's pull up the log screen. Turn it on, turn it off. So here we go. We've now got PoohBear video, Tom, Bosch. So this is actually the Midi-ox side of things. I thought I'll quickly just sort of go over this. So this is the other side of once we've actually sent a sys message out. And Midi-ox is really nice because you generate a COM object, and then obviously you have a few little keywords, but it will actually pass the sys message onto this subroutine for me. So it's really nice. I don't actually have to do hardly any heavy sort of lifting or programming side of things. And then it's just a case of manipulating the string that's come in. You may notice or recognize these numbers here because they're the same numbers. If I pop back to the actual, this is the, we're now in the service controller. You can see this is what I'm sending out. I'm sending out that particular number, which happens to be, hey, I'm a system exclusive message, and this is going to be my manufacturer's ID, which happens to be Head software, because we're coming from Reason. And then, yeah, so I'm looking for that, and then I'm saying, hey, am I sending myself to a clipboard? Am I sending myself to a file? Or am I just going to screen? So that's just setting up a few flags there. This is just working out, is the message one big chunky message, or is it split down? So it just does a little bit of management there. And this bit here, this simple little bit here, that's actually building the string up. So that's just build up a real basic string. So that's taken my hello world, which is now in hex. So it's taken all the hexadecimal numbers and just turn it back into hello, you know, so that's all that's doing. And then we can work out, once that's finished, are we going to push it to a file? I've got a predetermined file. I could prompt and say, hey, which, I could do it that way, but I've said no, I'm just going to have a predetermined file because I don't really do it. Clipboard I do use, and to screen I use all the time. And that is it. There's nothing else to it. It's really is that straightforward. This particular script though does have a lot of other junk in it because I use it for other things, like I'm using it to send keys from my foot pedal underneath the desk. So the basics is just literally near at the top. Here we go. We just create a simple object. I load up a profile. The reason I load up profiles is because I have many MIDI ports, but I don't always have all my hardware connected. And if you don't have all your hardware connected, it doesn't always show up. And what I'm talking about there is here. So the imports and the outputs won't always show up. So here I'm actually missing my inputs for my E-Ray, so that's one of my other MPC controllers. Even though I've got some output ports, bringing the E-Ray stuff into here. And one of the reasons I was bringing it into here and sending it out and then sending it to Reason is because I can obviously just disable one of these ports, and that's it. That's 16 channels I've disabled inside Reason, whereas if I needed to do something inside Reason, I'd have to untick 16 boxes. So yeah, so that's all that's doing. So that's just loads that up, and it is just some straightforward stuff at the beginning. I'll go and read all the MIDI ports in. So I'm talking about these particular MIDI ports here. What have I actually got live? So I display that out, and then I work out, hey, have I got my E-Ray? Is it actually plugged in or not? Do I actually have my foot pedal plugged in or not? There's another USB port which I've got as well, which is a 5-DIN converter to USB. Yeah, and that's all it is. And then we can either divert MIDI or not. I don't, because of the way I work. And yeah, this message box just sits on the screen. So I have a simple message box like this, which is telling me that my MP ports are not correct or not connected because my MP controller happens to be turned off. And just press OK to end monitoring. This is such a lovely way of grabbing MIDI data out, I think, in Windows, really. It's absolutely superb. It's so easy to do and so easy to manipulate stuff within here. So yeah, that's one of the reasons why I use that in conjunction, obviously, with the Surface controller I'm using inside Reason. Now, I know I have spoken a lot about the login, but the main reason I've spoken about this is not documented anywhere at all. It's something that I came up with, so you can't just go off to Reason and look at some documentation to work this out. This is it here. This is the documentation, really. So I'm quite happy to make it available for people to download and use it for themselves. It really did help me. So let's get back onto it, and I know this next bit's going to start shifting up a few gears, but you've got documentation to fall back on so you can really see exactly what we are talking about. So let's have a very quick recap of what we've got going on so far. So obviously I've got some basic functions at the top, so we don't have to go over them really. We have our remote ini, which is automatically called, obviously, when the service controller starts, when you start Reason or you restart that service controller in preferences. So we go through, we read what sort of items we're going to add. As I say, I like to track the items because we're going to use them a lot more later on. And we've also got some outputs that are like auto outputs, which we haven't touched on yet. We've touched on our remote process MIDI, which is obviously that is called whenever you touch your MIDI keyboard, it passes an event. I tend to use the remote MIDI match to pull that event out because you pass it to the word match. If it's matched, it won't be null. So I have loads of statements, and the only other statement actually I haven't spoken about in here is one I'd use a lot, which would be either return true or false. Most of the time I have returned true because I've handled the MIDI message and I've done something with it. It could be that I want the MIDI message to come into me, fine. I may do something else, but I want Reason to handle it. And if I want Reason to handle it, I'd return false. So that false is saying, I haven't handled it, Reason's got to handle it, or I'd have returned true. I will put what I call my expensive stuff at the top of this function, and the expensive stuff would be something like a knob or a fader, because when you move them, you're going to get lots and lots of signals, so let's process them at the top. Something like a button, well, you're only pushing the button in and then you let it go, so that's what I refer to as non-expensive, so it doesn't matter, we can drop through things. It's just a speed thing, and we're only talking about nanoseconds, but whenever I do programming, I'm always thinking about optimization automatically on top. I may write code which isn't automatically optimized to start with, because a lot of the time I just say, does it work? Can I get it to work? Then I'd worry about the optimization. But I do think of that kind of thing also, like, well, what is more expensive? Can I hit that? Can I then drop out the routine? Fine, done. And then down here, we've got the remote delivery MIDI, which is a bit of a funny one because obviously we've got this remote delivery MIDI, and we also have this other routine which we haven't touched on, which we will do big time because I use it a lot, called remote set state. And that's where remote set state is when you move any control actually on the rack extension or VST. That function is where we can collect and say what's happened. That function's not called. That function, remote set state, is a bit like the remote delivery MIDI, which is it's polled regularly. You know, sometimes I think, well, why is there two? You could have rolled up the remote delivery MIDI into that one, but they try to keep it separate. I kind of understand why they're trying to keep it separate, so we can control our MIDI stuff and our MIDI controller there. This is to do with more of the Surface controller, and obviously this one here is the MIDI coming in. So the event, hang on a second, we haven't spoken about really the event. The event is, I say, it's a MIDI event that's coming in. What is it? Well, let's go and actually have a look. And this is the great thing, obviously, about having something like our Sendlog. We can easily come up here, we can call that table, which we had, table print. We're going to call table print, and let's actually pass it the event. If you noticed, I've put this event outside of the sustain, so this is my little sustain button, isn't it? So when I hit that button on that little LPK, it's going to actually run this routine. But I'm actually going to put it on the outside, so we're going to grab everything and actually have a look at the event of everything. If I put it inside here, the event it's going to be capturing will be this kind of information. So let's go and capture something else. So quick save, quick restart, pull my log up, and let's actually, I'm going to hit a note on my keyboard, and as you can see, here we are, PoohBear Video Tom. This is the remote process. This is what we've called, and this is what's actually inside the event. I'm going to release my key now, and you can see we get actually another event because obviously we've taken the key off. Interestingly, we've got this, so this means it's an array. It's also a table dictionary, so this is a hybrid table. So we can see in here we've got the mixture of data. So number one, and that happens to be 144. So in hex that happens to be 90. So 90 note on MIDI channel 1. This is my note number 48. So that would be around about hex 30. So that's the C key I press, so I can tick on that. And this is the velocity level. So 3 would be the velocity level. And yeah, I suppose I did hit it semi-hard. 128, that happens to be 80, so that is note off, and obviously, again, I let go of the C key, so that would be the same. Interestingly, the velocity is 127, so that's automatically 127. You'd think maybe note off might be velocity 0. We've also got this size, so that's referring to how big's the array. We've got a timestamp, so timestamp's quite important because when we use another function, which is called remote.handle input, we will pass that timestamp. Because we can't make up our own timestamp with MIDI, so we've got to use, obviously, that existing timestamp. The port number here is actually referring to the port in the Surface controller. So let me just quickly pull up the Surface controller, click on edit. So it's referring to this port number here. So this would be port 1, this would be port 2. Don't forget, we can have many ports set up. Like here on the P1, we can see many ports. Now we know exactly the information which is coming in on that event input. So we can use that to our advantage. Let's actually move on and actually look at some pattern matching, because we've got some pattern matching here and we've also got some pattern matching there. And so let's actually have a look at the relationship between them two things. If I quickly bring up the Midi-ox, there we go. What I'm actually going to do is I'm actually going to wiggle a control on one of my controllers, and we can see it coming in. We can see we're coming in on a CC, so that's telling me it's a CC. It's on MIDI channel 1, it's CC 28, which would be 40 decimal, and that's the value we're passing in. So let's actually go back to our code and actually do something with that. So what I'm going to do, I'm going to just copy and paste this because I'm quite lazy. So B question mark, so that means that, yeah, it's listening to all MIDI channels. That's fair enough. We'll leave it like that. As I said, what we're looking for is 28, and XX will be the parameter which is coming back. And what we're going to assign this to? Well, I'm going to assign this to param1, and I'm going to save that. What we've also got to do, update our MIDI controller, but there's another step I've got to do as well. In fact, I'll show you this step. So I'm going to come in here, and I actually want to use my P1. Now, it's going to come up with this little error because obviously I'm using it inside Midi-ox, which isn't a problem, because what I can do in Midi-ox, I've got a spare port in there. I've got my PoohBear port at the top, so I'm just going to point my P1 to my PoohBear. Cool, no problem at all. And then that means I can obviously come in here now and point this to PoohBear. There's PoohBear, and click OK. That should have restarted automatically, but I just do it anyway for belt and braces. So now we're actually up and running. So that should now be working. We're going to fire this off. That's going to come through. And, oh, no, hang on. We're going to fail. It's actually not going to work. Is it worth even showing you that it's not going to work? Well, here you go. Here's the controller. I'm actually going to move my controller, and I can see all the MIDI events coming through here, but nothing's actually working. And the reason it's not working is when we was playing around with our little bit of test code earlier, this return true should not really be there, because what we've said here is we've matched any CC number, we passed it into this particular routine, and then we said, well, is it this 64 our sustain button? And then I've done an end, and I've done a return true to say I've handled that control. Well, really, I haven't handled that control. That control will be there. So return true should be there. Because if it's not 64, it's going to drop out the end here. So that was my bad. So if I quickly save that, do a restart, bosh, 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 bring on good old that, and yeah, just move my controller now, I suppose, isn't it? And there we go. We're actually got control. Fantastic. Now, as I said, we're going to sort of build a relationship up between this and this a little bit more. So we've already got this bit of routine where we're saying, hey, let's go and find, in fact, we're looking specifically on MIDI channel 1. We could put a question mark in there, so it's exactly the same as up there. So let's do that just to keep it the same. I've already checked, so if it matches, obviously this is not going to be null, so that you're going to see a lot of these checks all over. And I've got this if statement. Now, I do tend to use a lot of else if, so I would put an else if after this, but today I'm not going to. I'm going to try and just to keep it a little bit, it looks a little bit smarter or easier for you to read. So this time what we're looking for match.y, and that's got to equal the equivalent of hex 28, so we know that's 40. We're not interested if anything's being pressed on or off, like with here we had a match 0. We're not interested in that because we're just saying, hey, we just want absolutely anything. I'm going to quickly put my end in now. So I just like to keep things in order. And what we're going to do with this, we're going to use a statement, as I said, it's called remote.handleInput. So that looks like remote.handle_input, and it's a function, but it's also, it needs, you have to pass it like an array or table. So I'm just going to push return a couple of times. Here we go, let's just do a nice bit of formatting. And the first item it's going to need is something called an item. That item is actually the index. So remember earlier I said that we had to come up here, and I would actually have my char equals the index, or hash items, which will give me the index number. So 1, 2, 3. I'm interested in this one here, pram1. So I'm going to take pram1. In fact, let's be cheeky. Let's do item number 4. This is where we need to pass it a timestamp. So I'm going to pass it a timestamp, and the timestamp we're going to go and grab from our event, because we looked at that earlier, so that's rather handy, wasn't it, that we looked at that. So we need that timestamp from there, and the final thing we need to pass it is a value, and the value in this case we can go and get matched.z, because that's what's holding the value at the moment. So let's have that. And what I would usually do, as I say here, is I would say return true, and that would actually stop any more processing. But I'm not. I'm going to leave it out just for this moment, and you're going to see why in a second. So I'm going to save this, save. I'm going to restart my service controller, I'm going to pull up reason, and I'm going to now move that control, and if you look, you can see the A and the R, so that's the attack and the release, moving at exactly the same time. That's because this pattern here, this is the automatic side, and I've said to it, I've left that in there, so I could just delete that out, because you don't actually need anything in the inputs. But as I say, preferably, Reason can handle automatic inputs very efficiently, much more efficiently than us actually writing this bit of code. So even though this is a small bit of code, but this bit of code is also grabbing. So this is actually grabbing, saying, hey, I'm going to item number 4. As I said, item number 4 is 1, 2, 3, 4, is parameter number 2. Parameter number 2, we do know, if I switch back to here, is my release. So there's param2 release, there's param1 to attack, and that's why that's all working. As I say, obviously I can remove that out of there, and I can also in here put return true. So let's do that. bring up the reason, start moving my control, and you can just see just the release is working only, and the attack isn't. That's because we've actually said we're going to stop, so the automatic input is not handling it. Now, very, very quickly, obviously there's nothing stopping me here going Sendlog, process, and then obviously we need something sensible, like I might say, hey, let's go and have a look at the item number, or name. Let's go and look at the item name, equals, ... Now, items is saying in the remote init, which we set up. We are looking at index number 4, so make sure we put a 4 in here, and that's why I tend to start using parameters, so I don't have to keep worrying about it. And what we're looking for, we're going to be looking for a value equals something. In fact, let's do a little bit of space in here, just so it makes it look just a little bit neater. And double dot, and we want the value, and that's coming out of matched.z. There we go. Let's save that, let's restart that, let's pull up reason, let's pull up the log, here's the log, and if we start moving that, here we go. So that's moving, as you can see, we're getting our log, so we know where we're coming from, remote process MIDI, tick, parameter name is parameter 2, tick, which we know about, and that's the actual current value, which is 62, which looks about right. Obviously we can put it right to the bottom, so we've got a 0. By the way, this little bit here which has popped up, this is my APC. Basically every 5 seconds, if it notes one of these parameters changes, it dumps the whole lot of information out for me. So it's a bit like a bit of a debugger. And if I push it all the way to the top, and there we go, we've got ourselves a 127. So there we go. We now know we're working. We now know this here, Sendlog, once again, it's giving us that warm feeling that this is being called correctly. And as you can see, by having this return true, or I could put the word return false in, or I could leave it out altogether. I tend to always put the returns in the correct place. I know I've done it wrong earlier, but I do try and put the returns in so I know if I'm handling it or not. So even if I put a false in there, at least I can say to myself, I know I'm definitely passing it back, and there's nothing further down trying to capture that particular code. As I said, we can delete that altogether, and the other parameter will still keep working. What I'm going to set up now is a button, because my buttons can have feedback, so I can obviously turn a light on or off if the button's enabled or not. More importantly, it means we can do something actually on the rack extension or VST. We can use the function remote set state, change items, and we can do feedback. We can also do it automatically, so we can have a look at both ways, just like we looked at both ways for the input. So the first thing I'm actually going to do, as I've already got that highlighted, I might as well put my pattern in. So again, it's just a case of going off to Midi-ox. Here's Midi-ox, is it all on the screen? I don't know. I'm going to hit my button a few times. There we go. So I can see that was 38. Brilliant. So I was going to put down 38. Done. Got to give it a name. Let's call it, let's be sensible this time. I am going to call it button 1. And up here, I'm going to make something which is equal to button 1. So I'm going to grab that one there. We could put it towards the end. Why not? Just do that there. So this is going to be the name button 1. There you go, button 1. And the input type, we're going to actually make a button. There we go. Now all I've got to do is update the mapping to include that. Let's do a quick save. So in the mapping, I've got my button 1, and I'm pointing that to oscillator on or off. It's a nice big button we can actually see something happen with. So I've restarted my Surface controller, and this is what we're going to be looking at here. So when I hit my button, it comes on. When I hit my button, it goes off. Just a little side note, my controller, or the Nectar, you can actually set up in different ways. So I think as default internally, there might be set up as what's called a toggle mode, which is quite annoying. So when you press the button, it actually sends out a high signal. When you let go of the button, it doesn't do anything. When you press the button again, it sends out a low signal, i.e. 0, and then obviously let go doesn't do nothing, and then again it'll press high. So that actually acts as a proper kind of toggle button. At the moment, I refer to it as a normal button at the moment, so when I press it down, it's going to send out a high signal. When I let go, it sends out 0. Now, the button within reason, or should I say this button parameter, is expecting a high signal and a high signal. If we think it's expecting a high signal and a high signal, and don't forget at the moment I'm sending out a 1 and then a 0, then a 1 and a 0, and I'm pressing it and I'm letting it go. What I can do here is I could say I'm going to give it a value 1. Making sure it says equals. may look unusual that I've actually put that in quotes. It's a string, this particular value here. So let's do a quick save. I'm going to restart reason. Let's bring up reason. And now this time I'm holding my button down. We've got it on. I'm going to release my button and it turns off. On, I'm holding the button down, release it, off. So we've effectively made a trigger button. But I wouldn't actually do my trigger buttons like that, but that's something you can sort of bear in mind and go, oh, okay, that is how we can do a trigger button. So we'll do that a little bit later. We'll turn this button by using some modes and we'll turn it into like a trigger button, and you can obviously learn how to do that. But for now, I can either remove that altogether or I could even just put X in there. So it's going to take this X and it's going to turn it into that value. I'm going to set some auto outputs up now, but I'm also going to be swapping my controller out because I've got another controller where I've got some really fancy flashy lights and it just needs a little bit more of a setup. So because we're going to be doing some auto outputs, at the top here we've got button 1, we've got an input button. We need to say what we're actually going to be sending out as well. So I'm going to say output equals, it's going to be value. So that sets that up. Down here I actually need to set up, or more to the point down here, well yeah, I need to do both. I need to set my pattern for my new controller. Now my other controller doesn't actually use CC numbers, so I'm actually going to put this in here, and we'll talk about this in a minute because this is actually going to cause a little issue. But I'm going to cheat. I'm going to grab this, copy this down here, I'm going to put this into here as it's all on the one line. In fact, let's just format it out just a little bit. There we go. By the way, you don't need that last comma. I just happen to leave them there because they come in handy. Now, the big difference between this is we need to say what we're going to, because this is obviously a question mark. I'm pretty sure if you actually leave a question mark in there, it actually defaults to channel 1. I'm actually going to be writing back to channel 6 because on that particular controller, it uses different channels to do different things to the different lights. I'll be talking back on 00, so that's not a mistake. That is actually like the number. So just as we had 38 or got 28 up to here, 40, that is the same thing. And we're going to be returning X. Now the big difference is over here, this is now the wrong way round. We will say X equals, and we'll have the word value there. Now usually, again, default, you might not have that there, but I'm actually going to leave that there because I'm going to be wanting to change my colors, and I'll talk about how I can actually change my colors and how that will actually work and all the rest of it. So all I've got to do is quickly save that, do a quick change on my preferences to point to the new MIDI ports, and I'll be good to go. When we turn the on and off, we can see we're actually sending feedback to the keyboard. But we've actually got a different issue, is when I push this button, we're not turning this light on and off. And it's easy to get lost with this one, of why this is failing. And there's a very simple solution to actually make it work. Now, this is not maybe obvious what's actually going on here, but if you break that down, what does that actually mean? Well, it could mean 90 or an 80. Well, hang on a second, so what could this break down to? Well, that can break down to a 90 as well. I know we've got a question mark, but that could easily break down to a 90. So what there's a hierarchy in matches. So this top one is actually nicking that particular button because it's actually sending out a note and it's sending it off to the keyboard. So the simple solution is going to be we're going to take this and we're going to put it above this one. That's simple. So if I now hit Control S, quickly go and start, then we go back to reason. So this is now turning out on and off. This should now turn this on and off as well. So there we go. Now the next thing I'm going to talk about is this output value. So at the moment, this output value is either going to be a 0 or a 1. That means we can times a number by it to get any color we want on our actual keyboard. What you might have with some of them, you may have something like that, 127 times by the value. So obviously 127 times by 0 is 0, but if it equals 1, it'd be 127, so you're sending out that full amount to back to the MIDI controller because it might need it. Some MIDI controllers need to be above 64, you know, they really do vary. Now if I remember rightly, I can't quite remember my colors, but I'm actually going to change that to a 6. I'm just going to quickly start and stop my controller, and then we're going to quickly come back into here, and you can see the color's already changed already. So there's a way I can actually start changing my colors quite simply. But this is, as I said, the automatic way of doing things. So now what we're going to look at is the good old function remote set state, and we get that up and running. Now, where you actually decide to define your functions down to you, but I have a simple rule that I like at the very top to have my variables, then I have my own personal functions, then I have the remote init, then I have the remote process MIDI, then I'll have the remote set state, and then I'll have the remote delivery MIDI. Honestly, I always do it in that particular order, so whenever I open up any of my sort of Lua files, I know exactly what or where I need to go to find a particular function. Now, remote set state actually passes out an array. So this is going to be called changed items. So this has an index of all the items which have been changed. So to start with, I'm going to do my local process, because that's what I like to do. So let's put that in here. Let's put it in brackets and quickly type in remote set state. Done. Because the remote set state and the remote delivery MIDI, these are both polled. So it's obviously this is polled every few seconds. So we need to, or should I say it's polled a couple of times a second, and it could be even more. We need to manage it. So we don't want to obviously run code which is no need to run. So the basic premise I always put in here is I'm going to go for hash items change. So how many items are in there? If there's no items in there, this won't be called. And then I can just say then. So very simple little quick test. The next thing I'm going to put in here is a Sendlog. This isn't necessarily a good thing to put in here because of some of the things which can come along. And on its own, actually I'm going to use a get items. On its own, I could put the number 6 in there because that's what we're interested in to do with my buttons. But what the issue here is, I don't know what items I am bringing out. So we can actually write this slightly differently. And I'm going to put this in, say, to call out a 4 pairs. And the table I'm going to call, obviously, is the changed items. And now I can put this inside there. And that can be value. So that's going to come back with an index number. So I'm going to save that. We need to bring up the log. And then what I'm actually going to do is restart the controller, and what should actually come up is everything, because it's basically what's happened is it's switched on to Europa and it's going through and it's saying all the parameters have actually been changed. So the items are being populated when we switch between devices. So when we go from Europa, say, to Thor, all them parameters will be repopulated. So here's param 1, obviously, param 2 is our device name, Europa, and here's our button 1, which we're quite interested in, which happens to be obviously there. So now, when I press this, you see we're only going to get the button come up. As I said, we've got to be careful how we manage these things, because if I now bring up, let's see if I can get this on the screen at the same time at the top here. If I now move, say, something like the ADSR here, and I only have to move it a few times, you can see we've really jumped up quite a few, or we've pulled out quite a few bits of information. Now the whole point of using the remote set state is obviously we can now send out and control our controller. So when we push this button, because at the moment this button here is actually being managed by the auto. So let's actually have a little bit of fun with this. I might as well stay here and explain some other things as well, what's going along. So I'm going to do a for I loop, just a basic for loop, and I'm going to go from 0 to 39. And the reason I'm going to go from 0 to 39 is because this is 00, because it's a note number, and it happens to be 39. And so obviously we can reference every single button on this controller. What I'm going to do to reference it, I've got to write myself table.insert, because I'm going to populate my MIDI to-do list. So I'm going to populate this up with some MIDI I want to send out, and then my remote delivery MIDI will actually go and send that out for me. We need to do the MIDI, which is called remote.make MIDI, and then we need to build ourselves a MIDI string. Now, 96, or that happens to be channel 7, note on. Channel 7 on this keyboard means bright light. Channel 1 is like a very dim light, and so on and so forth. And different channels might make the lights flash and make them flash faster, so on and so forth. So if I was focusing just on this button here, and I wanted to make it, I think we said red, I think we said was 6 earlier, didn't we? If I was to put that pattern in, this would come along and it would turn that button on and make it red. But it'd never turn it off. It'd always turn it on. In fact, it would turn it on 40 times. It'd send out 40 MIDI messages to say turn it on, and it'd just stay on constantly. It won't ever come on and off. So we need to manage that kind of thing. So this, as I say, is my note. So let's first of all manage that. And the way we're going to manage that, I'm going to say hex. I'm going to turn something into a hex, and what I'm going to turn into hex, I. So the first time I comes along, it's going to be 0, so we're going to turn it into a 0, 0, then 1 will be turned into 0, 1, so on and so forth. Definitely going to need a space because of the formatting, and now I need a value at the end here, because obviously if it's a fixed value, as I said, is either going to turn it on or make it that color and never ever change. So we need to get something back which we're going to be changing. So again, I'm going to be pulling back a decimal value, so I'm going to need to convert that into a hex, and the value what I want to pull back will be from the changed items. There's a function we can use which is called remote get item value. Whoops, value, there we go. And we need to obviously now pass it the item which we're interested in, and obviously further up we've got it here, so I can actually just use the word value. If I was to use, I could put like 6 in there, because we know 6 happens to be button 1. It's always going to get that button 1 value, and if I'm turning that button on and off, it'd actually pull that value out. But what I'm actually going to do in here is obviously put the word value, so we can make it a bit more flexible. So I'm going to save this. I'm actually going to pull the log up, so you can see everything sort of scroll up, but obviously the final thing I need to do, well, I can actually do this. I could probably push this button here, and we've got everything turned on, push it, turn it off. And of course, I can also do that from here. But let's actually have a quick think about what is happening when I press this particular button here. Because when I press that button there, if we come up to the very top, we've got auto inputs are coming in, so I'm pulling my button in. I'm going off and actually updating what's obviously in the remote map file, which happens to be obviously turning that oscillator on or off. That oscillator on or off is now raising a message here to do with the remote set state. So it's saying, hey, I've changed some items, and that pushes that out, and then I capture that and I push it back to my controller. I could make this a 1 because further up we didn't remove the auto output. So if I do a save now and do a quick restart on my controller, you can see this has actually gone red. So this is the auto input and the auto output are being managed, this particular button now, and obviously the remote set state is changing all the other colors. But there's nothing stopping me obviously using this button here to do the same thing. So by turning off the auto output, it's obviously turning that button off, but the set state is doing all the other buttons. So it's good to understand the relationship between the two. So obviously what I would have done is I would have just deleted that line out, and I would have managed everything inside here. Inside here. Now you've got to be a little bit careful of what we're doing, because what I haven't said to you yet is what happens, say if I'm here and I'm moving this here. Look what's happened to all the colours. What's going on? And the reason these colours are all changing is because it's taken this value, because we haven't actually tied it down specifically to our oscillator button. But more importantly, every time I was moving that, we're sending out near enough 40 MIDI messages all the time. So by moving that control up and down, before you know it, I've sent out, or I've changed that item 50 times, and then it'd be 50 times 40, because I'll be sending out 40 MIDI messages to change the colors on the controller. So you, as I say, you've got to manage your stuff or think about it carefully, but using things like the Sendlog and using things like Midi-ox, you pick these things up and you can suddenly go, ah, right, I've got to be very careful. And I've done that with a lot of my code. I've worked something, it's working, and I suddenly look in the back end and I can either see the log going absolutely mad, or I can see Midi-ox going mad, and I think, okay, I've just got things in a slightly wrong order. I just need to make it more logical. Now, obviously, one of the things I could do here to obviously resolve that issue kind of straight away is just simply say something like, if value equals 6, then we're going to do something, and that, which would be, obviously, we can then run all this sort of information, and I can have a simple end there. There we go. Save that. Restart my controller. And now, obviously, from here, if I'm here, it doesn't matter how many times I'm obviously moving that. Nothing's going to happen. If I bring it a little bit on the screen, there we go. And if I turn that on and off, obviously everything's working. And that is how we can make it very specific. Of course, here I wouldn't actually hard code the number 6. I'd use a variable, like I've said in the past. Now, one of the final things I want to actually talk about in this particular video before I wrap it up is modes. I know I touched on them very, very briefly earlier, so let's actually go and quickly whiz up to our, here we go. So here's our device name, and we've given it 2 modes, one called normal and one called OTF. So what modes are in a nutshell is a way we can actually specify something in our mapping file. So I'm going to say device name is normal or device name is OTF, and then that in turn will affect how we're actually coding in our codec file. So we can obviously make branches, that's the whole point. So we can take different logical routes, but it's being controlled from the mapping file. So here we've obviously got ourselves device name, and it can be norm or it can be OTF. And if I quickly drop down into our mapping file, you can see here's OTF, what we set for Europa. Now down here is what I refer to as a norm, but we don't have to specify norm. Now that word norm could be anything. You could obviously make that word anything. I refer to it as normal because it's like normal mode. If you don't add anything, it'd be normal mode. Can you remember, like an hour and a half ago or plus, was doing all this logging, was outputting all this lovely stuff. So here's our keyboard, mode 1. Here's our damper pedal 1. That's a default. Parameter 1. We don't have any modes set for these. And then here, device name, we suddenly have something set, and it's mode 2. So mode 1 is default for absolutely everything, even if you don't have any modes sort of referenced. And if you do have something referenced and you're using it, it will then say mode 2. So actually, let's put that a little bit into play. So I'm going to come up to the top, and I'm going to actually add myself some variables, blah, 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 and we're going to add some stuff here, because this is how I would track things. So I'm just going to say local device name equals, this will be the device name. I tend to put rubbish in here because we're going to do a check later on. And here I'm actually going to add another one which we haven't set up yet. So we're going to quickly set this one up. And this is called device label, and that's going to equal blah, blah. Then I'm actually going to set one other one up, and I'm going to call this device, and I'm even going to break my own naming convention by making that uppercase, OTF equals, and as default I'm going to make that equal false. So we're now going to return the device name into the device name. We're going to go and grab what's the device label, so let's go and grab the label actually off the device. So it's probably going to say Europa 1 or whatever it's going to be, and then we're going to set a flag to say, hey, is this device an OTF mapping or not? So we're going to come down here. The first thing I'm going to do is add that device label. So in here, it's going to put the word label. That would do. It's going to be a text. We don't have any modes for the label, so I'm just going to remove them off. So we don't have any modes for that. That's fine. Now, before I quickly move on, just think about what I've done. This is, again, I know I keep labeling the point that I'd use variables to reference the index, because now I've just added an extra line in. This is now moved from index 6 to 7. We've just set index 6 in that bit, hard coded it to say, go and do blah, blah, blah. Obviously, if this had a variable defined here to get that reference number and I had it set, it doesn't matter how many things I add or remove, it's all going to follow. So that's why it's so important to do that. So anyway, we've got ourselves a device name and we've got ourselves a device label. We actually haven't set the label yet, so let's go and quickly set the label. And the reason I was going to set the label is because it's going to look a little bit weird. So I'm going to put in here device label, that's no problem. And what we're actually going to reference is device name. It's not this device name. This has actually come from something called the reason document. And I have done a video on that in the past. So I'm grabbing the device name, which happens to be the label. So this is actually the label, which is on the side of Europa or whatever device you're looking at. So that's going to go to device label. The device name, we've hard coded that, so we set that per scope, so per device. And obviously it's the same with the OTF. But yeah, so don't get them two device names confused. So now we've set them, let's actually go in, actually do something with them. As I said, that's now no longer valid, is it? So that's got to be a 7, but hey, that's something else altogether. This is where they'll be updated. So in the remote set state, when I change from Europa, say to that DrumSynth 500, that device name will change. So remember, I've set rubbish at the very, very beginning. I have a real simple piece of code of saying, if the device name is not equal, and here's a command you haven't seen yet, which is called a remote get item. In fact, there's a couple which start remote get item, and the one we actually want is value. So there it is. So we're going to grab the value back, and we need to know the value. So we do know that's index 5. Again, you know, that's what I'd reference. So I'm saying the device name doesn't equal that. And to be honest, I'll also in here have a piece of code and say, or device label is not equal to the same sort of thing, remote dot get item value. This time it's number 6 because that's the label. So one of them don't equal. It means either the device is changed, but we could go from a Europa to another Europa where the label has changed. And you might do this, or I definitely do this because I need to then say, hey, I've changed devices. There's a lot of things I need to update on my controller because I've now moved across. So you've got to manage the lot. You know, it's not a simple case of, hey, I'm just selecting a new device. You've got to manage everything that goes on. Obviously here I can actually decide to say, well, which one of these has changed? I don't know which one's changed, so I'm going to just pretend that they're both changed. So I'm just going to say this, and I'm going to grab this, put this here. So now what I've done here is I've just simply updated the device name with the new device name and the device label with the new device label, if it's set or not. The other flag which we haven't touched on yet is obviously device OTF, and there's another command we haven't spoken about. It's called remote get item underscore mode. There we go. And again, we need to put the index number 5 in here, aren't we? So yes, sorry, we're getting it from the device name. Now, if you remember, I said this is going to return a number back. I prefer to track it as a true or false, so I just simply in here will say I'm after 2, so does 2 equal that? If it does equal 2, that will return true, or it will return false. So now obviously here, the reason I like to do it that way is because I can say things like if device OTF, then, and obviously I can write myself some code in here and go blah, 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 blah. So I've now said, I'm an OTF map, I'm going to go and do X, Y, and Z, or I might even say, if I'm not an OTF map, obviously I can put a simple else in here and then go ABC. Now modes you can make as easy or as complex as you want. If I go and look at my Akai APC, obviously I've got myself an item here. As you can see, this is how I do my indexing. So every time I add something, I put it to an index so I know how to reference it. But here you see I've got loads of different modes here. Norm, like I said, I've got trig, a skip, these groups, and these. Actually, what you're looking at here is going to change on what's called in it, as in, have I assigned this parameter to a button? If it's assigned to a button, then these are all buttons, and obviously if it's a trig or not, it's a button. That word skip is actually referring to randomization. Should this item be skipped from being randomized? So I can actually set defaults to say, yeah, so like the master volume level, I might say, yeah, never randomize the master volume level or something. Grouping is something else altogether, and that can be on a button or an encoder or a fader or something, so it can be any kind of control. So they do vary what they're actually going to do, but obviously the big thing is, if I said to that, hey, I'm going to skip, so I don't want you to be in my randomization, I can't also make it 3-way. It's one of these options. So that's the downside, is that it's only one option. But as I said, they are very, very powerful, and it comes down to what you really want to do with it. Hopefully I've given you enough information to actually go off and start building your own codec files. You can get a lot more obviously information from that codec manual, but hopefully I've covered the real basics, and obviously I've given you some extra. I can't stress enough how much that Sendlog will really sort of change things. Even if you don't use the Sendlog and you use the error and raise errors, it is so helpful going down one of them routes. As a quick recap, as I said, my variables usually at the very top, then I start having some variable tables, and then I'll have my functions, and then I start having their functions remote in it, remote process MIDI, then into the remote set state, and then finally the remote deliver MIDI. As I say, if you look at, say, like this code here, this is the APC, so this is to do with my APC controller. You can see it's actually a humongous amount of code what we've actually got in here, because you've got to control absolutely everything, and it just goes on and on and on and on and on and on and on. And in fact, the smallest routine probably is the remote delivery MIDI in this particular case, and that's it. It's just not much there in that remote delivery MIDI. If you're still with me, well done for actually getting this far. I am going to be doing another video. Don't forget, I'm not just like leaving it here. I just felt this was all generic stuff. I've kept it quite generic, and I'm starting to touch on very specific stuff maybe into the way I start to code, which is obviously a personal choice. So I thought I'd do that in another video, but hopefully this is enough for people to be getting on with. So thank you for watching, and bye for now.